Good afternoon. Thanks for coming for one of the last talks on the first day. So I just want to talk a little bit about how you can make Windows timelines, which is something that's very commonly done in incident response, and how you can do it quickly and easily. So what is this talk about? It's about how do you create timelines for a Windows system. And this is something that you can do in minutes, not hours. If you've ever used other tools like Autopsy, you know that it takes a while, right? Here's a good example. 2 weeks ago, I was in Norway doing a training class, and they had asked, hey, could we do some stuff with Autopsy? And I said, sure, we'll do a little bit of Autopsy. So at 9 o'clock, when we kicked off for the day, I said, all right, everybody, here's a 26 gigabyte image. It's not very large. Why don't you go and start ingesting that into Autopsy now? Because around 2 o'clock, 5 hours from now, we're going to be using it. Everyone did. 5 hours later, most of them weren't done. Autopsy was still chewing away on that little teeny tiny 26 gigabyte image. The other thing that's nice about what I'm going to talk about today is it's very flexible. If you use a tool like Autopsy, I'm not beating up on Autopsy, by the way, it's the best value out there. But if you have a view in Autopsy that's not exactly what you want, that's what you got, right? So this is something that you can do where you have a lot more flexibility. It's going to be backed up to a database, so you can do all the queries you would ever want. Also, it doesn't cost anything. It's using Python, some shell scripting, and MySQL as a backend. Now, some of you might prefer a different database. Well, whatever. If you like Postgres, go ahead and use that one instead. And you can also easily create timelines either chronologically or on a file-by-file basis. So why should you care about this anyway? Having a timeline can be really helpful to determining what happened. You're looking at a system, you think there was a breach of some sort, and you're trying to get a better picture. And normally in an investigation like this, it's kind of an iterative process. You learn a little bit, you learn a little bit more, and you get a little bit more of the puzzle, and you can start zooming in certain time periods. So having a timeline is great when you can look at what files were changed, accessed, etc. during a certain time. Now, NTFS, which is the new default file system for Windows, in fact, if you have a modern version of Windows, you can't install it on anything else. You can't install it on FAT anymore. It just doesn't work because some of the features in NTFS are required in order to run Windows. So NTFS stores timestamps for all of your files and directories, and it stores them in a very redundant way. So there are more than one place where you're going to find these timestamps, which is not a good thing for consistency. Also, there are some pretty complicated rules that do tend to change from time to time on how these timestamps should be updated. So as a result, you can have attackers manually modifying timestamps, and it's kind of easy to detect that they've done that. So I'm going to give you a 5-minute tutorial on NTFS. Some of my students who might be here are really disappointed by this because they get an entire semester on NTFS, but I'm going to try to teach you in 5 minutes what you need to know at least to understand timelines. So in NTFS, every file is a collection of attributes. So these attributes include things like standard information, and standard information has what we call MACR times, modified, accessed, created, or record change times. And every file has at least one file name, and that's in a different attribute, and guess what? It has those exact same timestamps. It also will contain at least one data attribute. So the data, the actual contents of the file in NTFS are an attribute as well. And these attributes are stored in something called a master file table. So a master file table is this massive thing that's usually about in the middle of your partition. And it contains entries that describe every file and directory on that system. So directories are also a collection of attributes. It's kind of like Linux, where everything's a file, everything's an MFT entry. And these attributes are the same. They have standard information, they have file names. They also have an interesting way of storing the directories themselves. They have this tree structure, they have something called an index root, and if they grow a little bit beyond like 3 to 5 entries, they have things called index allocations. So index allocations are this tree structure stored out in clusters on the disk. So these attributes are all stored in the MFT. And guess what? Those directory entries that are stored out in these index buffers and index allocations also contain macro times. So now you've got at least 3 different places that you will have all these timestamps. So here's just a little screenshot that shows you part of an MFT entry. It's showing a $90 attribute that is an index root. This is actually for a root directory. And you can see there's a $A0 attribute, which talks about some of these index allocations, those clusters that also contain directory information. By the way, this tool is called Active@ Disk Editor. It's a free tool. If you go to disk-editor.org, you can download it for Windows or for Linux. And like Autopsy, it's a great value, right? It's free. It does have a couple little quirks, but overall, it's a pretty decent tool. A little bit more about these timestamps. So these timestamps have a pretty good resolution. They are in hundreds of nanoseconds, or 0.1 millionths of seconds. And they store the offset since January 1st, 1600, which is kind of crazy. You know, if you look at Linux timestamps, they have the epoch of January 1st, 1970. If you look at FAT file systems, they have an epoch of January 1st, 1980. So for NTFS, they said, hey, let's go back to 1600 because we need file timestamps. They go back to 1600, right? Because they had a lot of computers back then. So I don't know why they did it that way, but they did. 64-bit unsigned integers. And it's a lot better than the FAT timestamps. FAT timestamps only had 2 seconds of resolution, so we've gone from 2 seconds to 1/10 of a millionth of a second. Of course, Linux, by the way, is better. Linux goes to 1 nanosecond, not hundreds of nanoseconds, but you already knew Linux was better. The other thing that's different with FAT, for the access times, it's not actually an access time, it's a date. There is no time for that field. And there was no record update time for FAT. So that's something else that's new with NTFS. All right, so enough about NTFS. I think that was about 5 minutes. And you know at least enough to get something out of the rest of this talk. So how can I build a timeline very easily? The first thing I want to do is I want to extract some time system information from a file system image. So if you do any forensics on a system, the first thing you're going to do is make some sort of file system image using a tool like DD or something similar. And then you want to analyze that. So to analyze this, you want to first extract that MFT itself. So you can extract it as a file. And now you have this file that you can analyze, and this makes things a lot faster. So the stuff I'm going to discuss today is actually some scripts from this book, this teeny tiny 3-pound, 554-page book. Now, you don't have to buy the book, although you're certainly welcome to buy the book, but all of the scripts that are in that book, and I believe it's something like 9,000 lines of Python, or maybe it's 11, I don't know, it's a lot. You can go to windowsforensicsbook.com and you can download every bit of it for free. All right, so you don't have to buy anything if you don't want. But you can use some of the scripts I have there that allow you to extract any file based on its MFT entry number. So you can use that to extract the MFT itself as a file, which hopefully some of you, aka my students or past students, know is MFT entry 0. Right? So this is helpful for speeding up some analysis. Also, occasionally that MFT thing, they try really hard not to have it fragmented, but it can happen, and that makes your life easier. So you extract this, and then you can also supply to the script I'm going to talk about today a image file. And the way that that works is if you give it an MFT file, it will go through every MFT entry and it's going to pull out those timestamps from the standard info attribute and from the file name attributes. If you give me an image file, I'm also going to go out to those data clusters, to those index allocations, and I'm going to pull all those timestamps out of the directories as well. So now I have 3 sources of information for every single file. So how does this script work? Kind of an overview. It's going to go through that MFT, extract that information, and then it's going to get those index allocations as well. So just to give you an idea what it looks like, it's pretty basic. Okay, this worked great when I tested it later. All right, you can get those later. I'm not going to go through that script, but it's a pretty simple script actually, mostly because I also have developed Python classes for all of the different entities that are involved with NTFS. So if I run this script, okay, like 5 minutes later, suddenly this came up on my other screen over here. Really? Okay. Sometimes it's a little flaky, I guess, when you go to the 2 screens, but anyway, so here I'm just running on the first line, I'm running this extract script, and the nice thing about the script in NTFS, one other advantage forensically over FAT is that NTFS, if you delete a file, all it does is change 1 bit in the MFT entry. There's a bit that says this entry is in use, and then it also goes to a bitmap and says, hey, these clusters are available now. So undeleting the file is super easy. So I have a script that lets me extract any file by its MFT entry number, and it doesn't matter if that file is deleted or not. You can just pull it right out. So I run that script, and I get my MFT itself. Now, normally that MFT table, the whole thing, is stored in a file called $MFT, and that, of course, wreaks havoc on some of your Linux systems. It just makes your life difficult when you have $ in your file name. So I automatically rename it to $MFT. So I extract it, I give it an offset to the start of my file system, and say I want entry 0, please. And you can see it took 1.3 seconds. All right. So far I'm 1.3 seconds it's taken me. So we'll add this up later. And then I will call my script that's going to get that MAC timestamps, get all that information. And that took a whopping 10.8 seconds. So far I'm up to like around 12 seconds or so that it took me to do this. And I did a quick WC-L on that file. And that file was 282,364 entries. And I generated that in a couple of seconds. So step 2 for this process, I need to create a database. So if I need to install MySQL, it's pretty easy. On most Linux systems, you just say sudo apt-get MySQL-server, and it'll install the clients as well. And then I need to create a new database. And for that, you can use MySQL admin-u, and then you give it your username -p, which means please ask me for a password, and then the name of the database you want to create. And then you create a table. I apologize that this is a little bit messy because it's all on one line in my slide. Again, all this stuff you can download off the website. And you go ahead and you do it. So here I'm creating my database. Okay, another 3 seconds. So I'm up to like what, 15 seconds or so. And here I'm entering that SQL statement to create my table. And it was 0.33 seconds. So we'll round up 16 seconds so far. So it's taken forever, just like Autopsy. All right, so now let's do something. Let's take this data, so that the data is in a CSV format, comma separated value format, and that is very easily loaded into MySQL. So I run this little query here. I run the command load data in file, and then I give it a file location. Now, something I should warn you about with the file location. By default, in most Linux systems, there's a setting that's enabled, that's a security setting that says, hey, you can't load files from any old place into this database. And does that sound like a good idea? Like someone compromises your web server, they upload some files to your web server directories, and then they suddenly import stuff into your database. That's kind of a bad thing. So the standard place that in most cases you can install stuff from is varlib mysql-files. So you want to take that CSV file that you created, copy it over there, import it, and all this does, it looks kind of complicated. The real complication comes in because of this here. The fact that I have all these dates and times is why I have these funny things where I have at modify date, at create date, and then down here you can see I'm using stir to date, and I'm saying this is my date and here's the format I'm using. Because as you well know, there are many different date formats here in the US. We tend to do things like month, day, year. Other people tend to do day, month, year. And IT people often like year, month, day. And it's a little bit cleaner when you do it like that. So this is 6.42 seconds. Well, let's round up. Okay, so we're like 23 seconds or so far. So now we've loaded those 284,000 something rows into this table, and we want to populate a table called timeline. So the timeline table is basically a cross-reference table. So if I go back here a second and I say, well, what is the file table look like? It has all that metadata. It has all my timestamps. It has things like file size and file name. And that's a nice proper table. It's even got a key. You notice at the bottom it says primary key recno. So it's got this integer key. And so I create another table that's pretty simple, but this is what we call a cross-reference table. So it has some values from the other table, but notice it doesn't have any primary keys or anything. So it just says, all right, what was the operation? Was it modify, access, create, or record change? What was the source? Did it come from standard info? Did it come from a file name? Or did it come from an index allocation? What's the date? What's the time? And what record in the file table does it refer to? So then I run 4 queries, one for each of the Macker times, that will insert into this table based on the other table. And each of these queries took, well, one of them took 4.6 seconds, and the others took 3-ish or so seconds. So I'm still under a minute here. And guess what? I'm done. All right. So in terms of execution time, in under 3 minutes, I managed to do this, right? Which I think is pretty good. So now I'm on to the fun part. What do I want to do now? Now I want to actually run queries. Well, what queries? Whatever you want. Right. So there are a couple of standard queries that you might want to do. A standard query would be to look at things sorted chronologically. Another standard thing would be to say, hey, all right, let's look at a particular file. So this file has an MFT entry number. What are all the references to that file? You know, are there multiple index allocation references? Do they agree or disagree? You know, what's the story with this thing? So if you have a large result set, you can save it to a CSV file and then import it into LibreOffice Calc or something similar, some spreadsheet program. It's a little bit easier to view. So let's make this a little easier. So here I have a pretty simple script. This is a shell script. Now, one thing I will say about scripts that I tend to write, you might say, Phil, you know, your shell scripting sucks, and I would accept that, okay. But I like to write shell scripts that are very straightforward and easy to understand. So it is true that I could make this script shorter, but I don't want to, right? So on the left side, I've got your standard shebang bin bash that just says, hey, this is a bash script, please pass it to the bash shell interpreter. And here's a usage function that I define. So if you don't give me enough parameters, I yell at you and I say, I wanted a database name and a starting date and an ending date, which is optional. And the bottom part says, did you give me not enough things? If you didn't, then I'm going to call it usage. Otherwise, you go to the right column. This is the real deal, where actual things happen. So the first part says, if you gave me less than 3 things, then run this. Now, all I'm doing here is I'm going to pipe this part where it says select, operation, etc. I'm going to pipe that to MySQL. So I don't know, how many of you do any Linux shell scripting? All right, a couple of you. So this is a little trick that you can do. You can use cat and then less than, and then some sort of token. And basically what happens is it will take all the text that follows on the following lines until it hits that token, which typically people use things like EOF, which you can see down there after a couple lines. And then that command is run. All that stuff is sent to MySQL. So this is just a standard query that says, okay, I want to look at this timeline and I want to look for dates after a certain date. And then there's an else clause, and it says, all right, if I got to the else clause, it's because you gave me an ending date as well. So it's a very similar query, but if you look at the where clause, you'll notice that there's another criteria. It says, and timeline date, started date, $3, the last thing you passed in, is less than this date. Right? So that's all that's going on here. It's nothing terribly spectacular. So now I can run this. I just did an example on the same 26 gigabyte image. And I said, okay, what happened from 2015, 1201 to 1204? And it gave me a result in 2.6 seconds. Right? Now, let's go back to Autopsy for a second. Let's just say I was using Autopsy. I'd still be running this a long time, right? We're well under 2 minutes here of total execution time. You might say, yeah, but that's execution time. Okay, you could like listen to this talk even and download all these scripts and run them, and you'll still come out ahead of Autopsy. Remember I said 5 hours later, Autopsy still wasn't done with the initial ingest of this image. So from here, you could optionally import this information into Calc or something similar. And I just wanted to point out one thing that's really important. When you import a CSV file, and by the way, when you do a query in MySQL, by default, it's going to tab separate your data that's output. So make sure that you've checked the little box that says separator tab. That's one of your options. That's number one. And number two, for most fields, it's going to figure it out. But for dates, it can't, because again, there are so many different formats that people use for dates. So for each of those columns, you should go and down at the bottom where it says fields column type, instead of standard, you need to say date and then give it the format for the dates that you used when you ran the script. And then it'll show up in, well, this looks better on my screen than it does projected because the resolution changes, but you'll see something kind of like this. So that's one common way of looking at this data. Another common way is to look at it on a file-by-file basis. So here I have another script, very similar on the left. That's just setting it up, giving you a usage statement. And then on the right, I have a slightly different query where it's going to sort things and order it by the MFT entry instead of dates. And this is what that looks like. So you can run it for all of the entries, or you can run it for a particular entry. In this case, I just ran it for a particular entry, mostly because it all fit on one screen. So I could do a screenshot. And it was a whopping 4.5 seconds to get that information. So here, now you can see I have a bunch of modification operations for index buffers, standard info, file name, and then I have a bunch of access updates and a couple index buffers there, 2 file names, and standard info, right? And some of these dates don't line up, right? Some of them are slightly different. So that brings you to the question, is this right or not, right? So since all these dates aren't the same, you might think that there's a problem. So the next thing I want to talk about a little bit is trying to understand these timestamps. So first, a disclaimer. Microsoft can't seem to decide what to do with timestamps. This is true not just with NTFS, but also with FAT. And it seems like the rules change a little bit from one version of Windows to another. And this is likely to continue happening. So what I'm going to say right now is true today. Right? For versions of Windows today, this is how they work. Now, if you go to Microsoft's website and if you start asking questions like, what happens if I take something from a FAT file system and I move it to an NTFS file system, or the other way around, that's even more complicated. So you can Google it. They have a really nice knowledge base article on this very thing that I would encourage you to look at. But for today, we're going to keep it simple. And we're going to talk about what happens to these different fields when you do things like copy a file. So when you copy a file, everything gets changed except for in the standard info attribute, the modification timestamp does not change. Right? Everything else changes, and this is on NTFS, modern Windows, when you copy a file. What about when you access a file? Nothing changes except for the access time in standard info, but that's only true if you're running an old version of Windows, something that's older than Vista. So when you do any kind of forensics in Windows, what you find is that there's like new Windows. New Windows is Vista and newer, and then there's old Windows like XP and older. You know, sometimes you get like the really old stuff where occasionally like, hey, it's Windows 95. Wow, imagine that. Somebody's still running that stuff. But something that I get asked quite a bit is, okay, so, you know, talk about file system forensics and some of this stuff. Does that cover Windows 10? Now, it looks really different. If you look at Windows 10 versus Windows 7, it looks rather different. When you look at it forensically, there's almost no difference. Right? Windows 10, from a forensics perspective, is almost the same thing as Windows 7. It's just the external, the user interface that's changed a lot between those two different versions of Windows. You know, if you look at things like the registry and what's in the registry, it's all pretty much the same between 7 and 10. So, interestingly enough, you access a file and it doesn't change the access timestamp. Doesn't that seem kind of counterintuitive? I accessed the file, why didn't you change my access timestamp? Well, it turns out that the only place that changes is in the directory entry. So this is what happens in the MFT. Yes, sir. I didn't quite hear that. Yes, I was going to get to that. So the question is there a setting that you can use to force it to update the access time? So it turns out in Windows, if you have an NTFS file system, which is what we're talking about today, we're not talking about FAT at all. And the reason for that, again, you can't use FAT for your primary file system on a modern version of Windows. There is a registry setting called NTFS Disable Last Access Update. Right? So, flashback for a second, a couple minutes ago, we were talking about timestamps, and we said for NTFS you have hundreds of nanoseconds, and for FAT you had an access date and no time, and you had 2-second resolution. So it's kind of like Microsoft giveth, all of a sudden, hey, let's give you an access time. And then, ooh, performance sucks. And they took it away. Right? So they came up with this registry key, NTFS Disable Last Access Update is what it is. So if you create this key and you set the value to 1, it will disable updating of those access timestamps in certain conditions, such as if I go to a directory, either with my file browser or on the command line, it's not going to update the access times. So I don't have an easy way of saying, hey, somebody, some hacker or somebody else went into this directory and did stuff. Unless they actually modify things with the files in that directory, I won't be able to tell. Now, if you go to Microsoft's website, they will recommend that you disable those updates if your performance is poor. Have you ever seen a well-running, optimized Windows system? Have you seen anyone in here ever thought, my Windows system is so freaking fast that I couldn't possibly do better? Okay, that doesn't happen. So by default, today, that thing is enabled. So NTFS disable access update. If you look in your registry, you will find that key is enabled, set to 1 almost all the time today. Okay. That's a good question. So that's accessing a file. So what if you modify a file? Okay, if you modify a file, the standard information attribute will change the modification time. Interestingly enough, the file name attribute will not change the modification time. So if you're new to this, you might look at an MFT entry and you might say, hey, these differ, and that's bad, right? And you might suspect something was wrong. But it's not. It's actually okay. So that's modifying a file. If you deleted file, guess what? Absolutely nothing changes. None of these timestamps change. It's great though, because it just flips 1 bit and you're like, all right, the file went away. So if you look at the directories themselves, that's going to be updated. But everything else, it's still there. So you can very easily undelete files. You might have bought utilities to undelete files on Windows systems, and it turns out in some cases for FAT file systems it can be rather complicated, and sometimes you just honestly have to guess, especially when it's FAT32. Part of the reason for that, FAT32, you have the cluster number for your file where it starts, and it's broken up into a high word and a low word, and depending on what version of Windows you're running and how you deleted the file, for unknown reasons, Microsoft will zero out the high word of that cluster number for FAT32. So it can be almost impossible to recover a file sometimes in FAT, but with NTFS, it's just like, okay, just flip the bit, mark the clusters as being used, and it's all good. It's extremely easy to undelete in NTFS. Yes, sir. So the question was, how long do you have to get the file back? When what is enabled? Okay, so how long do you have to get the file back? I would say in most cases, as long as like if you just deleted it and you're like, oh crap, right? You can probably get it back. But if it's been a long time, it depends on how full your file system is, right? So if your file system is really full, what happens typically is that it will allocate clusters, and it just keeps on going to higher numbered clusters as it allocates space on the drive, and it only goes back when it starts running out of space. That's kind of the default behavior. There's some subtle differences depending on exact versions of Windows that you're running, but if you have a really full hard drive and you've been messing with the system and some time has gone on, the chances of your getting your file back start to go down a lot. But Does that answer your question? Yeah, and actually in this case, the question is, what about SSD versus not SSD? And it's really not all that different because we're kind of at the higher level. We're at that file system, operating system level. So at that level, when we say we're marking clusters as available, they're being marked as available by the operating system, right? So it's not that this part of flash memory is being marked enabled at all. It's just like a hard drive. It's really not any different between those two. So if we move a file to the same volume, here's what happens. We change the time in the file name, and now it's changed to the time in the standard info, which is kind of weird. And the same thing is true with the record change time. If you move it to a new volume, then all the file name stuff gets changed, and the access and record change time gets changed on the other system, right? Or I should say in the standard info. So looking at the timestamps, just to sum it up a little bit, the rules are a little complicated. I think you can kind of get a picture of that. They do tend to change over time, and attackers might screw something up. They might accidentally change things in one place and not another place, or they might change all the timestamps so that they're the same when they shouldn't be. Some standard tools are somewhat limited and a little bit slow. It can take hours to import your data, and you only get the views and the queries that they provide. So a great example, you look at Autopsy, it'll let you view files by their size. It'll let you view your files based on how long ago they were modified, but you can't easily combine those two things, right? It's one or the other. But since you have it backed up into a database, you can do it, and you can do whatever kind of query you want. I can say, I want a file that's at least 2 gigabytes in size, and it was touched in this date range, right? So maybe I'm looking for video files, for example, and that can help me to whittle things down. Now, of course, these timelines and these timestamps can always be spoofed. Everything can be spoofed. But guess what? Most people don't bother, right? It's true, occasionally you'll have an advanced attacker that's actually going to change these things, but most of the time they don't. It's kind of like, earlier, I don't know how many of you saw Phoenix's talk this morning. He was talking about privacy, and it was all about, hey, you don't have anything to hide, right? And you have governments telling you encryption is bad. Encryption is only used by bad people, right? Only bad people like privacy and things like that. So, you have people saying, oh yeah, you should just be able to, see that or not see that. But anyway, that's a little bit of a tangent. But so, and the other thing about this is just a little bit of scripting and some database stuff. It can be fun, and it can be pretty fast. So with that, we have a couple more minutes. If you guys have any other questions, or if you want to live dangerously, I might even, see if we can actually repeat this in a 3-minute live demo. Yes, sir. I do. Unfortunately, I don't have anything at this exact moment where it's done, where you can just access it for free. I do have, not to advertise for Pentester Academy, but Pentester Academy, I do have an 18-hour course in Windows Forensics that includes this and a lot more stuff. But if you guys want, depending if there's any other questions, if you want, I can actually try to do a 3-minute live demo, which is dangerous, I know, but. Yes, sir. That's a great question. The question was, what's the difference between MySQL and Autopsy, and why is it there's such a huge time difference? And honestly, the biggest thing is that Autopsy is going to read in all of that data, and it's not going to back it up to a proper database, right? And it's doing some other things while it's doing that ingestion. But if I only just wanted a timeline, then the script is a lot faster. And, you know, again, a big part of that is I have some Python scripts that interpret all the different structures in NTFS, and it'll rip through that pretty quickly, as we saw, and then take that and put it into a database, which is a lot faster because you start looking at all the rows. So, you know, this kind of leads to another thing. So you could take that CSV file and import it directly into a spreadsheet, and then you could sort it in your spreadsheet program. If you do that and you have a couple million rows in that spreadsheet program, you might lock up your computer, right? Your computer is going to be like, oh, what are you doing to me, right? So it's going to be very unhappy with you if you try to do that. So the difference is that with something like Autopsy, it's very similar to running that spreadsheet program. It's got so much overhead, and it's trying to sort it in part because it doesn't have a nice database that's backing this stuff up, like a proper database. And that's really the biggest difference, I would say. You know, they're going to have to pull everything into memory and try to do some sorting, whereas I just dumped everything raw into the database and then ran a SQL query, and it was super fast. So, yes, sir. Mm-hmm. All right, so the question was, can we interpret this slide? Okay, so this is telling us for whatever it is that's stored stored in MFT entries 65,261, what are all the references found in this file system that point to that file, right? And this is sorted by date and time. So you'll notice that at the top, I have 2015 to 3, so February 3rd at 7:09 p.m. The file, and the I indicates that this was gotten out of an index buffer, out of a directory entry. I have a modification time of that time for one file called main HTML, and then another file at the exact same time, main_1.htm. So it's got a long file name and a short file name, and those two directory entries agree. I also have file size information. I didn't mention it, but each of these things in the MFT, they have a number for the entry, and then they have something called a sequence number that's used as a double check. So this is the first time this entry was used, sequence number 1. That's what that means. So that if I have a reference to something that says sequence number 1, and I go in and look in that entry, and it says, this is version 2 of this entry, I know I'm looking at the wrong thing. I'm looking at outdated information. But so then the next line has that same timestamp, and it says from the standard info I have for main_1 HTML, I have that same timestamp, right? So I can look back at my rules and say, is that right? So if I look at a file that I changed, Okay, I went the wrong way. Sorry. So this file was modified, and according to this, the standard info should change. All right, so if we go back, here we can see that the standard info changed and those index buffers changed. So that tells me this is actually correct. All right. If I looked at the file name attributes and those had also changed based on my little table, that would be incorrect. So that would indicate to me that someone manually manipulated this information. Right? But this is a useful view, not just for detecting that manual manipulation, because honestly, people don't do that very often. Most of the time, people aren't that sophisticated and they don't realize that this is happening. I mean, you do occasionally get the more sophisticated attacker that will, but this just gives you kind of a history of that file. And it says, all right, here's the first reference to that file, and it was a modification time reference. And then I see some later references, and those were accessed, those were record changes, and also creation, right? So creation could be, it was copied, right? And that's where you have to look at those rules. But this just gives me a view, so maybe this is an interesting file. So let's just say I looked at my overall timeline, my chronological timeline, and I saw, all right, I looked at my registry, I looked at my event logs and such, and I saw around December 3rd, something strange happened that I suspect might have been an attacker in my system. So I'm going to start looking at all those files in that time frame, and I might want to look at them individually and then say, let me pull that out of that context where I said, all right, I've identified this particular file at 65,261 as an interesting file, potentially. Now let me just look at that file and all references to that file that I found in this file system. And this will even pick out things from, like, if I delete a directory, if I delete the whole thing, all this data is still there, right? So this is another way that I can see, all right, I thought it was around this time that something happened with this file, but maybe it was actually a different time based on data that got left on the file system. So that's kind of how you can interpret this. Now, this is probably not an interesting file. It was just like a random number I just picked to make this demo because it fit on one screen. That was my criteria. It fit on one screen so that you could see the whole command and how long it took to run. All right, I think we're about out of time. So I thank you very much for coming and enjoy the rest of your conference.